Hello learners, I am Dr. Subodh Kesharwani working with Indira Gandhi National Open University in School of Management Studies. The topic which I am going to talk today is measure of variation. In our preceding sessions we have seen that how the statistical analysis, how the research methodology and how the variation is going to play a very important role because there are certain constraints the average have. We have seen that measure of center tendency was exclusively talking about the averages, either it could be the mean, median and mode or arithmetic mean or geometric mean, but there are certain constraints when you are going to scatter the data or when you are going to expose the data. So in that case the variability and the variation is very important. The preceding session was more talking about the variation, but this particular session is focusing more on measure of variation. So when you are going to measure the variation, I think there are certain ways by which you are going to measure, and we are going to definitely talk about all those the measures. Either it could be the range or quartile deviation or mean deviation or standard deviation or coefficient of variation. So while going into the depth of this variation, I think the measure of variability is a summary statistics that represent the amount of dispersion in a data set. So how spread out, how you are going to spread out the values, and while measuring the central tendency, it describes the typical value, and measure of variability defines how far away the data points tend to fall from the center. So this is more analytical in nature and more more deeply talk about that. So we have talked about variability in the context of distribution of values. A low dispersion indicates that the data points tend to be clustered tightly around the center, and high dispersion signifies that they tend to fall further away. So in statistics, variability, dispersion and spreads are synonyms that denote the width of the distributions. Just as there are multiple measures of center tendency, there are several measures of variability. I think measure of center tendency, if we talk about, and we have seen in our preceding session that how the data is going to be spread out, and you are going into the depth of the individual characters rather than taking the average of that. So what we are going to do, we will talk in this particular presentation about interquartile range, the variance, the standard deviation, and how it will be going to determine the data in a best possible manner. So we are going to more talk about all those aspects. So prior to going into the depth of this topic, I just want to throw a light that we have already covered somewhere around 3 to 4 weeks, and these particular weeks have somewhere around 12 to 14 videos which were focusing on research and data collection, introduction to business research, then research plan, collection of data, then sample size, measurement and scaling techniques, and then processing of data, diagrammatic presentation of data, graphical presentation of data, statistical derivatives are there, and measure of center tendency we have already talked about. So what I mean to say that there is a quite linkage between the variability or the variance or the measure of variance, because it's a chain. When you talk about statistics, it starts with the chain. We have seen that how the sampling is going to play a very important role and how the hypothesis is going to be helpful. Either it could be the alternate hypothesis or null hypothesis. And in our coming sessions, you will find out when we are going to do the trend analysis. The third block, which focus on the relational and trend analysis, you will see that there is a great use of all these the terminologies which we are gradually covering up. Either it could be the measure of variance or the measure of center tendency, or the coming things are there. So this probability and hypothesis testing, and then it is going to helpful in interpreting and making the results thereof, and finding and finally help us in reporting the things. So this is the model which is there, and we will definitely talk about all those things. And if you see this particular chapter, which is a chapter 9, it focuses on the variation, which we have already covered, and significance of variation, why there is a use of variation, and then measure of variation is there, and then skewness and relative skewness is there. So when you are going to talk about measure of variation, I think which is a discussion of this particular today's presentation, and talks about the range, quartile deviation, mean deviation, standard deviation, and coefficient of variation. I think this is the slide which we have already covered, and we have seen that how there is a paradigm shift from mathematical average to positional average. And when you are going more into the depth of the mathematical average, you will find out that mean, arithmetic mean, geometric mean, and harmonic mean is is considered to be the mathematical average, whereas positional average is median and mode. So and if you more describe in a numerical manner, I think central tendency talks about arithmetic mean, median, mode and geometric mean, and then you have quartiles, and then you have variations. So we are here in this variations, in which talks about range, interquartile range, variance, standard deviation, coefficient of variation, and then shape is there. How you are going to, and it could be the bell shape or skewed, or right skewed or left skewed. So this is purely talking about the skewness, which we are going to cover in our forthcoming session. So now variation, if you talk more about the measure of variation, are statistics that indicate the degree to which numerical data tend to spread out an average value. It is also called dispersion, scatter or spread, etc. So variation may be measured in absolute or relative term, and measure of absolute variation are expressed in terms of the original units. For example, the temperature of a city in a day ranges between 50 centigrade and 470 centigrade, then absolute variation of the temperature is 320 degrees centigrade. So absolute measure is a possible way to compare two sets of data expressed in the same unit, that is kgs, rupees, etc. And we have seen in measurement that the homogeneity need to be very important when we are going to do the things in the or calculate the things in a unit manner. So in case the two sets of data are expressed in different units or in different size, the absolute measure of variations are not comparable. So in such a situation, the measure of relative variation should be used. So we would like to compare the variation of temperature about an average which is measured in degrees Celsius and the variation of the scale of cold drink given in rupees. So this type of distribution variation is obtained as a ratio or percentage, which we have already covered in our preceding session. We have seen that how the rates, ratio and percentage differs from each other, and we shall now consider in turn each of the four relative measure of variation which provide a numerical index of the variability of given data. So now what is the purpose of doing a measure of variation? So the goal for variability is to obtain a measure of how spread out the scores are in a distribution. A measure of variability usually accompanies a measure of central tendency as a basic descriptive statistics for a set of scores. So it's not like that when you are going to do the measure of variance, you are going to eliminate the measure of central tendency. It's not like that. So measure of central tendency is an important, the important ingredients when you are going to evaluate, the measure of variance, and this could be one step, next step in this direction. So you for taking a base, I think you start with the measure of central tendency, and then you can apply measure of variability, because measure of variability talks about scatteredness, talks about exploding the things and going more into the depth of the average. In our preceding sessions, we have seen that how the average was coming same in all the three cases as far as the marks scored by the student, but when we actually gone into the depth of the particular the ingredients, we find out that there is a huge variations. So these huge variations comes up when you have spread out the scores. So range is one of the first ingredients which would be helpful in measuring the variance, and range is the amount between your smallest and largest item in the set. You can find the range by subtracting the smallest number from the largest. For example, let's say you have earned rupees 250 in 1 week, rupees 30 in the following week, and rupees 800 in the third week. The range for your pay is varies from rupees 30 to rupees 800. So the range for the data is the difference between the largest value and the smallest value contained in the data set. First, reorder the data set from smallest to largest, that we have to put the number in the chronological order, and then subtract the first element from the last element. So I think if the example and we take an illustration, I think the 5 numbers were given, that is 4, 6, 9, 3, 7. Now what we have done, we have put it in a chronological order, in a number from smallest to largest. 3 comes first, then 4 comes second, 6 comes third, 7 comes afterwards, and 9 come at the last. So the lowest number is 3 and the highest number is 9. So now the range is what? Higher minus lower, that is 6. So the range is the difference between the lowest and the highest values, and this is a way by which we are calculating. Now age of student is there. So what we have done, we have put the number in the from lowest to highest, and then take a range of that, and range is highest minus lowest is 3. So this is the way by which we have calculate the range. Now quartile deviation formula is there, which is another way of calculating the things, and quartile is a type of quantile which divides the number of data points into 4 more or less the data. The interquartile range is a relatively robust statistics, also sometimes called resistance. So compared to the range and standard deviation, and there is a formula that quartile 3 minus quartile 1 divided by 2. So this is the way by which we have calculated. So now the interquartile range is almost the same as the range, only instead of stating the range for the whole data sets, you are giving the amount for the middle 50. It's sometimes more useful than the range because it tells you where most of your values lies. The formula is IQR, that is interquartile range, equals to quartile 3 minus quartile 1, where quarter 3 is the third quartile and quartile 1 is the first quartile. So you are basically taking one of the smallest values at the 25th percentile and subtracting it from the largest value at the 75th percentile. So this is the way by which you are going to do the interquartile range. I think the following is the if you see the graph, we can very easily calculate that how we have calculated. So the first quarter of data and the last quarter of data is going to be calculated. Now what is quartile deviation if we talk more about it? And quartile deviation, we have talked about, it's quarter 3 minus quarter 1 divided by 2, and quartiles are values that divide a list of numbers into a quarters, and then you are going to calculate it. And what are the 4 quartiles? Generally the data is arranged from the smallest to largest. So first quartile is the lowest 25% of the number, and second quartile is between 25.1% and 50% up to the median, and third quartile is 51% to 75% up above the median, and fourth quartile is the highest 25% of the number. So that is the reason we take a difference of the fourth quartile from the first quartile and divide by 2. So the semi-internal quartile range, also called the quartile deviation, is a measure of spread. It tells you something about how data is dispersed around a central point, usually the mean. So now there are certain merits and demerits of quartile deviation, which can force us to apply the different methodologies which we are using. It can be easily calculated and simply understood. This is beauty of the quartile deviation. It does not involve much mathematical difficulties as it takes middle 50% terms. Hence it is a measure better than range and percentile range. It is not affected by extreme terms as 25% of upper and 25% of lower terms. And when you are going more into the depth of this quartile deviation, provides a shortcut method to calculate standard deviation using the formula 6 quartile deviation equals to 5 this, and in case we are dealing with the center half of a series, this is the best method to use. So there are certain merits and there are certain demerits also. As Q and Q are both positional measures, hence are not capable of further algebraic treatment. That is very true. Calculation are much more, but the result obtained is not much of importance, and it is too much affected by fluctuations of samples. I think in our preceding sessions we have elaborately talked about the samples and how important the sample is, and there are certain methods by which the sampling is going to be done. Either it could be the random sample, which could be talk about the judgmental sampling, or the stratified sampling, or the random sampling, and on the other hand we have snowball sampling, which talks about the non-random sampling. So there is a use of sampling, and this is one of the way, and 50% term plays no role. First and last 25% terms ignored may not give reliable results. If the values are irregular, then result is affected badly, and we can't call it measure of dispersion as it does not show the scatterness around any average. So what we have observed that this quartile deviation have got certain limitations, and when you have certain limitations, there are certain other options which are available, and mean deviation is one step ahead to that. And this mean deviation gives information about how far the data values are spread out from the mean value, and this is the USP of the mean deviation. And there are certain advantages for using the mean deviation. The advantages of using mean deviation is that it is based on all the data values provided, and hence it will give a better measure of dispersion. So it is easy to understand and as well as easy to calculate. So if you see the formula of calculating the mean deviation from the mean is measure of spread. It tells you how far the values deviate from the mean. Remember that the deviation always is a positive number. You can calculate the mean deviation from the mean as follows. And if we take an example, I think the given row is 2, 3, 4, 5, 6, 6, 6 and 7, then the mean is what? The total number is 10. So we have taken a total of all these numbers and divided by 10, and 10 is the number of items, which comes to 4.8. So the deviations are 4.8 minus 2, the first number, it comes to 2.8, and then we have deduct all these mean deviations, all these numbers from mean deviation, and the result is this 2.8, 4.8 minus 2 is 2.8, then 4.8 minus 3 is 1.8. Like that we have done it for 4, we have done it for 6 and 7, and this is the way by which the mean deviation from the mean equals to 1.36. So what does it mean? That there is a deviation from the mean which is coming 1.36. So now we have standard deviation, which is again a different way of measuring the variance, and the standard deviation tells you how tightly your data is clustered around the mean average. A small standard deviation indicates that your data is tightly clustered. So you will also have a taller bell curve. A large standard deviation tell you that your data is more spread out. So smaller standard deviation and large standard deviation. So when we are going to talk about the scatter diagram, or when we are going to talk about in the bell-shaped curve, which usually we are talking here, I think there we can more talk about all those aspects. So now standard deviation tells you how spread your data is. It is a measure of how far each observed value is from the mean. In any distribution, about 95% of the value will be within 2 standard deviations of the mean. So this is the best part of the standard deviation, and in statistics the standard deviation is a measure of the amount of variation or dispersion of a set of values. A low standard deviation indicates that the value tend to be close to the mean of the set, while a high standard deviation indicates that the value is spread out over a wider range. So it can be quoted by the sigma, and sigma is equal to this population standard deviation, then you have size, and then x and mu is there, which is considered to be the population mean. So the standard deviation can be calculated by this way, and mean is this, and standard deviation comes to 1.83. So this is the methodology by which we are going to calculate, and there is coefficient of variation also, which is one of the last the measure of variance in probability theory and statistics. The coefficient of variation, also known as relative standard deviation. So this is also known as the relative standard deviation, and it is considered as a standardized measure of dispersion of a probability distribution or frequency distribution. It is often expressed as a percentage and is defined as the ratio of the standard deviation to the mean. So coefficient of variation, if you are talking about, the formula is small sigma divided by mu. So coefficient of variation can be calculated and interpreted in 2 different settings, and the standard formulation of the coefficient of variation is that the ratio of the standard deviation to the mean applies in the single variable settings. So in the modeling settings, the coefficient of variation is calculated as the ratio of the root mean squared error to the mean of the dependent variable. So in both settings, the coefficient of variation is often presented as the given ratio multiplied by 100. So the coefficient variation for a single variable aims to describe the dispersion of the variable in a way that does not depend on the variable measurement unit. So the higher the coefficient variation, the greater the dispersion in the variable. So the coefficient of variation for a model aims to describe the model fit in terms of the relative size of the squared residuals and outcome values. The lower the coefficient variation, the smaller the residual relative to the predicted value. This is suggestive of a good model fit. So the coefficient variation for a variable can easily be calculated using the information from a typical variable summary, and sometimes the coefficient of variation will be written by default in the variable summary. So this is the way by which we are going to do that. I think we have talked a lot about coefficient of variation, and we have seen that how this different kinds of variation, either it could be range, or this standard deviation, or or this quartile deviation, or the coefficient of variation is very important, because it's totally emphasized on the spreadness, it totally talk about the scatteredness. So I think this particular chapter, which was focusing on the variation, then talks about the measure of variation, and then finally we have a scatter diagram, which we are going to talk about in our coming sessions, and we will see that how important when you are going to evaluate the data, and how important the pictorial presentation is. We have seen in our preceding session that diagrammatical presentation of data and graphical presentation of data is also somewhat fruitful, but here this particular measure of variation can give you the trend analysis in a pictorial manner. So thank you, learners. In our coming sessions we are going to talk more about related to this particular chapter called measure of variation. Thank you very much.